Okay, in lesson 8, we're going to talk about solving rational equations and inequalities. So it starts off with a rational equation. It says every rational equation can be written in the form of f of x divided by g of x equals 0. So it's a function on top divided by a function on bottom. Remember, rational means fractional. So if f of x and g of x are polynomial functions with no common factors, then the zeros of the numerator are the solutions of the equation. And so we saw that in our previous stuff. Remember, we were looking for those x-intercepts, and so we said the shortcut was to set the, when we were doing the x-intercepts, we said that the shortcut was to set the numerator equal to 0. Well, that's what we're doing here, because remember, your x-intercepts is the same thing as your zeros, same thing as your solutions, same thing as your roots, okay? So we've already been doing that. So remember, though, to get rid of fractions, the first thing you're going to do is you're going to find the least common denominator of all the terms. And then we multiply each side by the least common denominator. But we have to watch out, though, for extraneous solutions. So when we multiply or divide an equation by an expression that contains a variable, the resulting equation may have solutions that are not actually solutions of our original equation. For this reason, you must check each solution of the resulting equation in the original equation. So because we multiply by a variable to get rid of a fraction, we can end up with answers that really don't work for the original. So you have to check your answer. So look at example 1. So here, first thing we need to do is to solve this, we need to find our least common denominator. Okay, well, both of these we can say are just over 1. And so our least common denominator, make sure you factor out all your denominators if possible. And so we need a 1. We need an x minus 3 super glued together because of the minus sign. And then I need another 1. But I already have a 1 up there, so I don't have to put a second one. The only time you'll repeat yourself is if it comes from the same denominator on any number. So 1 times x minus 3 is my least common denominator, or you could just say x minus 3. It comes out to be the same. All right, so we're going to multiply each side, which means we're going to multiply each term by that least common denominator. So let me erase this. Let me put my over 1s again. So literally every single term here is multiplied by the least common denominator. So let me write that down. So for my first one, for my second one, and for my third term. Now remember, the whole reason we do this is so that we can cancel out that denominator. So for this first one, the 1 is going to cancel. And so I'm left with an x minus 3 times an x. Put your single term first. That x there doesn't have anything, and then the x minus 3 is super glued together, so leave it together. Then we bring down our plus sign. The second fraction, the x minus 3 is going to cancel, so we're left with the 1 on the inside and the 1 on the outside there. So 1 times 1. Bring down your equal sign. The 1 on bottom will cancel, so we're left with x minus 3 times that 1. So 1 times x minus 3. And then we just solve this equation. So let's distribute our x plus multiply equals, and we can distribute the 1 or just multiply it. Either way, we end up with x minus 3. All right, because I do have an x and an x squared in this problem, this means I'm going to need to try to factor it. In order to factor, I need to set equal to 0. So my x squared is positive where it's at, so I'm going to leave it alone. So I'm going to move the other side over. So I'm going to subtract that x, and I'm going to add this 3. So I'll line them up with their like terms. So we get x squared minus 4x plus 4 equals 0. And then check, can you factor that? We can. So we can factor it, or you could use your quadratic formula if you wanted, or you could do completing the square. But so when I factor this, I come out with the factors of x minus 2 times x minus 2. And so I set them individually equal to 0 and solve. Now they're the same, so I could rewrite that if I wanted as x minus 2 squared equals 0 and solve that. So that means I got x minus 2 equals 0. Move the 2 to the other side, so we get x equals 2. And don't forget, this means it has multiplicity of 2. Now, all that really matters for us on this is that means that my answer is going to be there twice. And so we can see from up here that it was an x squared, which meant we should have 2 solutions. So we do have 2 solutions. They're just the same solution because x equals 2 counts for 2 of them. All right, but because we multiplied, our least common denominator that we multiplied by had a variable in it, that means we need to check our answer. So I'm going to come right here and do a check. And so I'm going to check when x equals 2, and I'm going to plug it into my original problem. So my original problem is x plus 1 over x minus 3 is equal to 1. So everywhere there's an x, I'm going to plug in a 2. And then I'm going to simplify it. So 2 plus 1 over negative 1. Now remember, when you do a check, you work one side and then you work the other side. So 2 plus negative 1, which is 1. I don't have anything to do over here, so just bring down that 1. 1 equals 1 is true, which means 2 is my solution. And I should have boxed that until I checked it. All right, so look at example 2. They step up their game a little bit here. It's a little bit harder looking. Got more to it. Remember, make sure your denominators are factored out completely first before you actually go find the least common denominator. So my first denominator is just an x. I can't factor it any further. My second one is x minus 1. I can't factor it any further. My third one is x squared minus x. I can factor that. It has a greatest common factor of x. So I'm going to take out the x, and it's going to leave me then with x minus 1 in parentheses. So now when I go to do my least common denominator, it's got to have the first denominator, which is an x. It needs an x minus 1 superglued together. Now we have an x up there, but we don't have a minus 1 superglued to it, so we're going to put that x minus 1 in parentheses to show it's together. And then for my third denominator, it's got to have an x, which we already have one, and it needs an x minus 1 superglued together. It's already got that as well, so you don't have to write them again. Remember, you want this to be the least common denominator. That way you don't have to have x cubes or x to the fifths and try to figure out how to do that. All right, so there's our least common denominator. Now, if you wanted to check the last thing, remember it's just a 0, so you could say it's over 1. But it's 0, so I'm just going to leave it as it is. All right, so we're going to multiply every term on both sides of the equation times that least common denominator. So I'm going to write it out for each one of them. So for my first fraction, I need to get rid of that x on bottom. So get rid of the x outside. I'm left with x minus 1 times x plus 2 on the top. So x minus 1 times x plus 2. Bring down your minus. Second fraction, my x minus 1 is going to cancel. I'm left with the x times the 4. Bring down your plus. The third fraction, the x and the x minus 1 to cancel. I'm left with nothing outside, but I just have that 2 that's on the inside there. Equals, and then the last term there, nothing cancels, but 0 times anything is just 0. So I'm just going to put a 0 there. Now I need to work this out, so this means I'm going to have to do FOIL or the box or distribute. So I'm going to do that. So it gives me x squared plus 2x minus x minus 2. Then here I just have minus x times 4 is 4x plus 2 still equal to 0. Now on this left side, let's combine like terms. So I have x squared. I have 2x minus x, which is x, minus 4x is negative 3x, and then negative 2 plus 2 actually cancels out. All right, so I have an x squared and an x, which means I need to factor. It's already set equal to 0, so I'm just ready to start factoring. So x squared minus 3x has the greatest common factor of x. So I'm going to take out the x, divide it out. That leaves me with x minus 3 equals 0. Set each of my factors individually equal to 0 and solve. So I get x equals 0, and I move the 3 over on this one, so I get x equals 3. But remember, before I can box them, I need to check them to make sure that they both work in the original problem. So I'm going to try to squeeze that in here below it. The 3 may have to move over some. All right, so when I plug in that 0, I'm going to plug it into the original. So 0 plus 2 over 0. Uh-oh, can I divide by 0? Right there it tells me there's an issue. I can't divide by 0, so that means that x equals 0 cannot be a solution. So then check the 3. So we have 3 plus 2 over 3. It's minus 4 over x minus 1, so 3 minus 1, plus 2 over x squared minus x, so 3 squared minus 3, and we want to make sure that it's equal to 0. So I'm just going to work on this left side. 3 plus 2 is 5 over 3, minus 4 over 3 minus 1 is 2, plus 2 over 3 squared is 9, minus 3 is 6. And so I could get a common denominator out of all of these. If I do, it's going to be 6. I'd multiply top and bottom here by 2. So I get 10 over 6 minus, here I'd have to multiply by 3. So 12 over 6 plus 2 over 6. 10 minus 12 is negative 2 plus 2 is 0 over the common denominator of 6, which is, I can't really see it here and put it down here, 0. When I work the other side, there's nothing to do. Bring it down, equals 0. It worked. So x equals 3 is my only solution. That x equals 0 is what we call that extraneous solution. So it worked for our equation that once we multiplied we ended up with, but it doesn't work for the original, so it is not a solution of our problem. Okay, so our only solution is that x equals 3. All right. So then looking at polynomial inequalities. So it says you'll be able to solve inequalities involving polynomials and rational functions using both algebraic and graphical techniques. Let's explore some common connections between inequalities and the positive and negative sign of the expression. To solve f of x is greater than 0, you're going to find the values of x that make f of x positive. And to solve f of x is less than 0 is to find the values of x that make f of x negative. All right, and so here's talking about the sign chart. And this is the same chart we used in 2.6 when we were doing our graphs there. So they use the number line. I'm going to change it into our chart. So it said, let f of x equal x plus 3 times x minus 4 squared. Determine the real number values of x that cause f of x to be 0, positive, and negative, and to show your work. All right, so let's look at this. So remember, it's just like what we did kind of before. We're looking at that table that we created. And so in that table, we had, I'm just going to use this here to do it. So we had our interval. We had an x value. We had a y value. And then we had the sign. All right, and so remember those intervals were formed by the x-intercepts and the vertical asymptotes. Well, how did we find the x-intercept? So remember, your x-intercept is where you set your function equal to 0, and we said if it's rational function, though, we could just set the numerator equal to 0. Now, if it's a regular function, like the one we have here in example 3, it's not rational, okay, so it doesn't have a fraction there, then we just set the equation equal to 0 and solve it. Remember, your vertical asymptote was the uncanceled factors of the denominator. Set equal to 0 and solve. So if we don't have a fraction, we're not going to have any vertical asymptotes. We would not have to worry about it. All right, so when I look at this one, we can tell, looking at this equation, it's not going to have vertical asymptotes because it's not rational. It doesn't have a fraction with x on the bottom, but we are going to have those x-intercepts. So we need to go find where they are. The x-intercepts, remember, is the same thing as your zeros. So that's what it's asking me for. So if we have x plus 3 times x minus 4 squared, we're going to set that equal to 0. Well, it's already in factored form, so we can just set our factors individually equal to 0 and solve. So solve this first one, we get x equals negative 3. And when we solve the second one, we just got that x minus 4 is equal to 0, which means x equals 4. But remember that exponent tells us the multiplicity. And we'll talk about that in a few minutes on why it's important when we're looking at our table. All right, so it's just got a multiplicity of 2. So we know our intervals then are going to be set up as negative infinity to the smallest one here, which is negative 3. Negative 3 to the next smallest, which is 4, and we would keep doing that till we get to the largest one, which is 4, and then you go from the largest to positive infinity. Now again, we'll talk about, do we use parentheses or brackets on the numbers here in a few minutes. But right now, I'm sorry, I jumped ahead here. Right now, those are my zeros. So my zeros are when x equals negative 3 and when x equals positive 4. Now, in order to find where they're positive or negative, that's where I'm going to finish filling out this table. And so remember, we pick an x value that is in between negative infinity to negative 3. And so let's pick like negative 4. Between negative 3 and 4, so let's pick 0. That's our favorite one, by the way, if 0 is not already being used, if it's not one of the endpoints. And then between 4 and infinity, so let's pick 5. So I'm going to plug each of these into the equation, and I'm going to solve it. So when I plug in x equals 4, I'm going to change colors over here. So when x equals 4, we get y equals 4 plus 3 times 4 minus 4 squared. I'm sorry, I shouldn't have picked, it's negative 4, excuse me. So negative 4. So that would give me, so negative 1 times negative 8 squared, which is negative 1 times 64. So we get negative 64. So it's negative 64, which means it's negative. Then let's plug in 0. So when x equals 0, our y would be 0 plus 3 times 0 minus 4 squared. That gives us 3 times negative 4 squared. So 3 times 16, which is positive 48. And so it's positive. And then we're going to plug in when x is 5. So our y value will be the 5 plus 3 times 5 minus 4 squared. So it's 8 times 1 squared. So 8 times 1, which is 8, which is positive. Now, before when we've done this, almost every time we've seen it alternate positive, negative, positive, negative, positive, negative. So anytime I see a positive, positive, or negative, negative, it makes me think what's going on. Did I make a mistake? But remember, the common number these have in common, these two intervals, is that 4. That 4 had that multiplicity of 2, which, remember, even multiplicity touches and turns. So it's either going to come up from the bottom, touch it, and then go back down, so they'd both be negative. Or if it's from the top, it would touch it and go back up, which means they're both positive, which is what we're going to see in this one since they're both positive. All right, so that's why the multiplicity, I go ahead and state it, because then when I see that plus, plus, or minus, minus in a row, I can go back and look and say, okay, is it supposed to be like that? Does it have even multiplicity? All right, so here I can see it asked me for B. Where is it positive? Well, it's positive right here between negative 3 and 4 and between 4 and infinity. So the interval from negative 3 to 4 and between 4 and infinity. Now I'm just going to use parentheses here, but we'll talk about when we change it to a bracket later. And then it asks, C asks, where is it negative? Well, look at your sign. It's negative right here between negative infinity and negative 3.